Next up today is terminal velocity, which is the maximum velocity an object can reach while falling through air. And it's all about the force diagrams here, so remember you always draw two. On the first you put all the actual forces acting on the object, and on the second you draw only the resultant force acting on the object. Okay, here we go. So the instant you step out the plane, you are not moving yet, and so there's no drag force on you. This means the resultant force is the same size and direction as the weight. This means that your acceleration is as big as it's going to be downwards, and so your velocity is going to get bigger. A little while later then, now you're moving. So there is a drag force on you, and this means that the resultant force is smaller. So that means your acceleration is also getting smaller, but you are still accelerating downwards, so your velocity is going to increase some more. This continues until the drag force has reached the same size as the weight. And then the resultant force on you is 0, your acceleration is 0, and you have reached the maximum velocity you're going to go for this situation. And so this is your terminal velocity for your current situation. But then you're going to pull your parachute. And so this causes an enormous drag force upwards. And that means that the resultant force on you is now upwards and really big. So this means your acceleration upwards is as big as it's going to be, but you're moving downwards, so that means you're going to slow down. So a little while later, you're now moving more slowly, and so the drag force is smaller. And that means the resultant force on you is also smaller, and so your acceleration is also smaller. But you are still moving downwards and your acceleration is still upwards, so that means you're going to keep slowing down. And so eventually you get slower and slower, your drag force gets smaller and smaller until once again it's the same size as the weight force. And once again the resultant force on you is 0, your acceleration is 0, and you have reached your new terminal velocity. Now you might think, is this one the same as that one? And the answer is no, because your parachute has a much bigger surface area, so your parachute doesn't need to be going as quickly to get the same size drag force. When it's just you falling through air, you've got to be moving pretty quickly to get a drag force that big on you, but the parachute doesn't. Parachute doesn't need to be moving very quickly at all to get the required drag force. Okay, and I'm pretty pleased with this terminal velocity question. I feel like this one's quite an unusual one, so pause the video and have a go at this. Drawing force diagrams, I meant to say. So what happens to your force diagrams and what difference does it make? Okay, so if our skydiver has more mass, that means that the weight force on them will be bigger. And that means that it's going to take longer for them to go fast enough for the drag force to reach the same size as the weight, because the weight's bigger, so the drag force is going to have to be bigger. So it's going to take them longer to reach terminal velocity, and also that means their terminal velocity will be higher. So how will this change the graph? Well, the velocity is going to keep increasing and it's going to keep curving. So it'll keep curving for longer, and then when it flattens out, it will be higher. Quite a nice question, that one.